Yeah, it's
Okay,
recording
take us
now.
away.
I don't know this. I don't think this is live, but this is recording to
You're
the cloud
recording.
somewhere.
Yeah, you'll get it later. Tell us what we're doing here and get started whenever you want.
All right, sounds good. So this is all about LSP and giving a background to the team on where we are with LSP and really doing a code walkthrough of the Go LSP implementation and the TypeScript LSP implementation. So I'm going to go ahead and share my desktop. So I just noted some points here for discussion's sake here. So basically, let me give you a brief background of the LSP. So the vulnerability research team are the ones who originally came up with this, and they really did a brilliant job of making a pretty generic LSP that could be used across for different purposes. And they are the ones who actually figured out how to, they wanted an LSP for themselves for code completions, and so that's how they kind of built a code completions LSP, which made us really realize the possibilities of where we could go with this. So that's essentially the background. So originally created by vulnerability research as a generic LSP, probably for some security features that they wanted to build in, and now it's been expanded for code completion and hopefully for other functionalities as we sort of pick up.
Да, это Дима, собственно, и посоветовал. То у него только второе поколение, это третье.
Ilya, you're unmuted.
Sorry.
No worries.
No worries. All right, so before we kind of get into the code, I just want to give you a brief, the vision of where we want to take this. So the idea is that we want to be able to support extensions for various IDEs. So there's, VS Code, Web IDE, all the JetBrains IDEs, Visual Studio, NeoVim, and a bunch of others. So we want to support this across the board, and not just the AI features like code completion and chat, but we want to be able to, support a number of GitLab features across the board. And so that's where the LSP idea really helps us. The idea is that we will build purpose-built extensions for the IDEs, which communicate with the LSPs. The LSP then goes ahead and parses the code and does all the sort of transformations that need to be done on the code to make it ready for various purposes. That then talks to the, let's say, the get suggestions endpoint, the chat endpoint, or whatever else needs to be spoken to on the GitLab side. And then once that response comes back, it's sent back to the extension, and then the extension can modify the UI as it needs to, right? So it'll call the sort of native extension APIs to do the things that it needs to. But the idea is all the complexities of mangling code and talking to GitLab and all of that is actually encapsulated within the LSP. Okay, and that's what makes the LSP idea pretty scalable. The fact that if we have all this logic in the LSP, if things change later, like our backends change, etc., we don't need to change all the IDs and extensions and publish new versions to the marketplace. Hopefully, what we can do is we can, upgrade our LSP, and then everyone is upgraded at the same time, right? And that sort of makes it pretty scalable. So the original LSP, as I already mentioned, was written in Go, right? So the question begs is why TypeScript? So one of the main reasons is we want to support Web IDE. And although we could probably compile Go to Wasm and run that on the web, we found that, and Marshall did some analysis on the fact that it wouldn't work, because we need to make essentially calls, network calls, etc. And any IO is kind of not permitted within any sort of Wasm container on the web. And so essentially in order to bring LSP to the Web IDE, we need to be able to support something that runs on the web, which is JavaScript. And so that's why we sort of got on this whole idea of using TypeScript. The second advantage of kind of using TypeScript is the fact that TypeScript, the JavaScript library, is quite well maintained, and it's also official. And so we always on the sort of latest version of the LSP protocol and things like that. That's easy to do because the TypeScript library is kind of the most maintained library amongst all the rest of the LSP client and server libraries that we have. Feel free to interrupt me in case anyone's got any questions, or just in case I've misspoken as well. Let me know.
Okay, at this point, when we are talking about the library, is it about the VS Code modules that you use across the code, right?
Correct.
Okay, so just to make sure. Thank you.
All right. So with that, I'll walk through the Go code first. Like we'll start with that because that's the kind of the bulk of the functionality currently exists in the Go code. And I'll briefly talk about the TypeScript code as well. But I'm sure you guys have already gone through that and you're quite familiar with, I don't know, there's not too many lines of code there anyway. So basically, the two core functionalities of the Go code, and I'll walk you through like this diagram that I drew out earlier. But I'll actually get into the code and show you where that is, because then it's easy for you guys to reference as you're sort of writing the TypeScript LSP. You can go through the code and understand exactly how it flows. But essentially, in the Go code, we use this library called GLSP, which is a public library for creating LSPs in Go. I don't believe there's any official library maintained by the LSP team for Go. So this is sort of a community maintained library which exists. And so we built a custom server on top of this GLSP. So instead of looking at the full LSP protocol, we kind of look at a few parts of the protocol. Namely, we look at completions and we look at diagnostics, right? I think those are two core parts that are being currently handled by the custom server. But before we get into what the server does, I want to briefly talk about the token functionality that exists. So today that the binary that we built for the Go LSP, that supports the ability to save tokens and to receive, to then use those tokens elsewhere. And basically all it's really doing is it's storing your personal access token in a location in your config directory on your machine. And so that's then used by the LSP to then reference that token elsewhere. So the idea behind the Go LSP is that you would say whatever Go LSP save token, and then once the token is saved, then you can actually use the LSP for code completions and things like that. So essentially, there's a save method of the token, which goes and it gets the config directory, which is sort of relevant to your operating system. So if it's a Mac, it's in like library application support. If it's like Linux, it'd be under .config. And then I think for Windows, it'd be like under app data local probably. I'm not quite sure, so don't quote me on that. And then the token's actually saved to the file system where it can be then retrieved by various parts of the application because they know where to retrieve the token from. So essentially, all we're really doing is saving the token to a location on the file system, which then can be retrieved. There's also a recently added check functionality, which checks that the token is still valid and things like that. So that also can be invoked from the Go LSP using its command line utility.
Shikar, that check of the token was the feature that Ash needed for NeoVim, right?
Yep, exactly.
Okay, just make sure that I'm following. Okay, go ahead.
So the GLSP module, so going back to the server, so the server is basically a custom server that we start up. It essentially looks at a few things. It looks at diagnostics, but diagnostics have not really been implemented yet. We don't do anything with diagnostics. Diagnostics are those little squigglies that show up in your files, when you made a mistake or a warning or an error or whatever. So those have not been implemented, but then you also can do code suggestion, and that's the part that's been implemented. Now, one of the brilliant parts of the original writers of the LSP is the fact that they've made it quite pluggable. So what you can do is you can plug in different providers into the Go LSP. The only provider that we have plugged in currently is the code suggestions provider. But as you can imagine, this can be used to plug in other providers in the future. So let's say we had a separate chat provider or something that provided completions for, I don't know, our CI YAMLs or something like that. We could plug those in as well. Okay, so you could essentially have different providers doing different functionality. So all of them, you could have different code suggestion provider, for example, one for CI YAMLs and one for code suggestions and one for, I don't know, some other part of GitLab, right? And so you could plug in different providers into your server, and then each provider then implements code suggestions or diagnostics or all of any of those methods. The other thing that's also done is we have this redaction provider that's also added on, especially for code suggestions. So we do redact like passwords and stuff if it's in the code. So we automatically do that in the Go provider using Git leaks. And basically what we're doing is loading a TOML file containing a bunch of regular expressions, and we check the input text against with those regular expressions. And if any of those match, then we mask that before actually sending it on to the code completion endpoint. So we're making sure that the customer inadvertently is not sending like passwords or something to the code suggestions endpoint. And so that's essentially what's happening here. So the redaction part, it essentially uses the Git leaks brilliant regular expressions to actually filter out the content that's being sent. And then finally, all we do is get the token and make the API call. In order to get token, we refer to the token that's in the file system, essentially. Yeah. Any questions before I go into the actual code for Go?
I wanted to check about the redaction. It's it's interesting part. Is it something we need to implement in the TypeScript version as well? Because it's kind of a cool feature, but I guess yes.
It's a good question. Andre, do you know if like the redaction is a must-have feature for the TypeScript language server?
I don't think we have discussed it deeply on it. I think ideally we'd like to keep parity with Go. I can keep. Is it already? So I'm guessing it's not implemented yet, Shakar. Is it?
That's correct. Yes.
Okay, so I'll create an issue for it, and I'll check how hard of a requirement that is. The one thing that I can probably theorize is that, so we don't have a lot of users on Visual Studio yet, so there's not a lot of people using the Go language server. But I'm guessing that's sort of like a security concern that some customers might have from very early on. So I would assume that yes, we would need to implement it. But I'll create an issue, and then I'll validate whether it's a hard requirement or not. And I'll keep you posted.
Yeah, that sounds good. Thanks, Andre. So like I mentioned, there are like two core commands of the, this is in main.go. That's a good place to start so that you can see what's happening. Excuse me. So basically we've got these two core commands, which is serve, which just starts the server, and then GitLab token, which is then used to like save the token and stuff like that. And you've got this command called register token, which is basically used to save the token to the file system. And if you see that, all we do is, I'm just drilling down quickly here, but basically if you see, it calls this write GitLab access token method finally, which if you see, all it does is it writes this file, which is basically in your OS config, and it writes a token directly into the file. So if I go into, if I cat, actually, if I just show you the file without having to expose my token publicly. So if I go to library application support, and if I just look at my GitLab something, GitLab LS folder, you can see there's a token file here, and the token file actually just has your path stored in that in free text format. So basically what we're doing is, all we're doing is storing that token in the thing. And this is in token.go. You'll be able to see that it's in package token and then token.go. Okay, so all it's doing is really saving the token in this directory, which is your user config directory, which is essentially either xdg config home or library application support or app data or whatever. So it goes in any of these directories, right? Then we've got the.
Can I ask a question? Is it important to save it in the file system? Is something else using this token, or it's only the LSP and we can say keep it in memory or something?
That's a good question. Right now, it's only the LSP that's using it. Like ideally, we have the GLab CLI as well. I don't know whether we want to like reuse the same token that the CLI is using. Like that could probably help us if we wanted this, right? But again, we kind of have to define what that looks like. We have changed the behavior slightly for the VS Code, for the TypeScript extension, in the sense that you can pass the token from the server to the client. From the extension to the LSP as well dynamically, instead of having to pass the token when you are save the token prior. So that's possible with the TypeScript version of the extension.
Okay, thank you.
Okay, so going back, and I'll show you the main server logic as well. So if I go to run serve, I'll just skip over this. But basically, if you see, we're adding various feedback providers, and feedback providers, if you remember my diagram, if you remember, a diagram is these providers which you can set up. So the Go LSP supports more than one provider if you wanted to, right? So you could add various providers, like if, I don't know, the security team wants to build their own kind of scanning or vulnerability analysis kind of provider, they could do that as well. So basically that's what it lets you do, is have a set of different providers. And that all we're saying here is use this code suggestion provider as just one of the providers that this supports. And if you see, there's only literally only one provider being added at the moment, which is the code suggestion provider. So all that does is it starts up the LSP server, and then all the calls that are sent are actually added, are actually just delegated to the provider itself. So every provider needs to implement these methods, which is provide diagnostics for file, diagnostics for content, provide code suggestions, and then set client name and version. So these are the different methods that need to be there in each of the providers. Like I said, there's only one provider at the moment, which is the code suggestion provider. I hope I've not lost you guys here. I know some of you are not familiar with Go, where I'm just trying to distill it down as much as I can.
Oh, it's all clear. Thank you. Can I ask a question now? What's the difference between provide suggestions for content and for file? I don't remember. If you can go back to the
So that's in
type
here.
definition.
Yeah,
so it's for file and for content is what's the real difference? Maybe I'll understand it later. Maybe.
Good question. I don't know. This is a part of the this is pretty much a part of the LSP protocol. I believe diagnostics for file expects you to provide for a whole file the diagnostics, versus content or just a portion of the file needs to be provided as the for diagnostic. But I could be fully wrong here.
Makes sense.
So again, these are unimplemented pretty much. So if I go to the actual implementation of this, which is in package provider, code suggestion provider, you can see that these two methods for diagnostics are empty. So basically, we're not doing anything with it, even though it's there. So we're really not doing anything. One bit I did want to show you is the initialize method. Where is that? Let me try to see if I could figure out where initialize is being called, because there was one of the comments that sorry, this is just a bunch of methods. They're using I like I mentioned, they're using this GLSP server package for supporting the LSP. I will just show you quickly. Apologies for all the scrolling that I'm doing. I just don't remember where this is. So this is initialize method where we are actually setting the client name and version. And this is a change that Mike had made essentially to support the client name and version, so that we can send that for diagnostic purposes. And so that information is coming during initialize. So the extension is sending that information to the LSP and letting them know what the client version is, stuff like that. And then we're creating a bunch of server capabilities here, saying, hey, these are the capabilities that the server supports. And one of the ones we are supporting here is text document kind full. Again, that was one of Mike's comments is, hey, this is the kind that we're supporting right now. And so that is important to know. And then, of course, we send it the fact that LSP sends it back the fact that it supports code completions. So it sends this resolve provider as true, saying that we support code completion and stuff like that. So basically, this is just the response to the initialized result, which tells us what capabilities the server has or the LSP has that the extension can use. And you'll find that in serve.go under server. That's a useful file to know, and you can basically see some of the methods that we're capturing and then things like that. Going back, I just want to quickly show you the actual implementation of the code suggestion provider itself. So we are just implementing two methods: that's set client name and version and provide code suggestions. And this is basically the only difference between our version of this and this version is the fact that it does redaction before. So all it's doing is it's using the GitLeaks redactor to actually redact content. And the way it does that is it loads a whole bunch of rules, which are basically just regular expressions in the STOML file, which is there. So it just loads a whole bunch of these regular expressions, and it compares the content that we get, right? The content below and above the cursor. So I don't know how familiar you are with the code suggestions API, but basically right now, in order to get code suggestions, what we do is we send the content above where the person currently is and the content below, and we send those two attributes to the code suggestions API, and then that returns us with the content in the center, right, the middle of those two things. And so what we're doing here is redacting that sensitive information if it existed. So what we're doing is we're erasing that information if it existed. And that's pretty much it for this. That's all we're doing is provide code suggestions. All it does is it calls the API, gets the suggestions back, and then displays them, sends it back, and then you see them as code suggestions essentially.
Okay. I don't see the just going a step back, the client information sent anywhere. So it's like it's set on the provider, but it's not like sent to the code suggestion server, or am I missing it?
Oh, we're sending content before and after so when the client calls provide code suggestions, it calls it with the file path, the file that is being called for, and where the cursor is currently. Those are the two things that is an input.
Yeah. But like previously, when we create when provider is registered, like the client, so we set the client name and like version or something. So it's not like used anywhere.
Oh, it is used. Sorry, let me show you where it's used. So we set the client name and version here, and then I'll show you where it's used. So basically, when we are creating this user agent here, if you see, to send, we add the client name and client version to the user agent essentially. So we send this as the user agent string, and then the client name and version are appended to that user agent string.
So this is similar to what we need to build on TypeScript to generate the user agent string. I pasted the issue in the chat.
But that's like here it's the client part, right? So it's like basically what the extension would be doing, like this code you're showing right now. Like the part I don't understand where the code suggestion server uses this information, or it doesn't.
This is to the code. So when we are constructing the request to code suggestions, we're doing two things. We're adding the authorization header, right, to say the bearer header for authorization, and then we're also constructing this user agent string.
Okay, so it makes sense. So sorry.
Yeah, well, right now we've been using it if you want to like debug and check the logs to see which extension is making those calls. That's useful to know and keep it identified in case we have like an extension doing a DOS on the server. We know who to blame. Go ahead, Shikar. Thanks.
Yeah, so that's essentially where it's used. So the only place where it's used is essentially the user agent string. I'm just trying to think of whether I missed anything, but I think I've covered most of what the tool does. Quickly, if you wanted to build a tool yourself, you could just do make build, and that'll actually build the binary for this. It's got a very long name, GitLab code suggestions, language server experiment, and then you could just do help and see the methods. They basically serve and GitLab token.
All right. Thank you. Time for TypeScript.
Yep. So quickly through the TypeScript language server, again, very simple. We just accept a few parameters, the port, the host, because we want to support self-managed, the token, and the mode, which is either TCP or standard in. Now, once we get this information, all we do is really we start up the TypeScript server. Somewhere here, we start up the TypeScript server on that particular port, and we call this essentially the setup connection method, which is, again, it's all the SDK. You know, there's no like brilliant engineering going on here. It's quite basic. And what we're doing is we are handling the various methods of the LSP. One is initialize, like I showed you, where you send the capabilities, right? There's another method called onChange configuration, and this is really used to set the token dynamically, right? So if the configuration changes on the extension side, that is then communicated to the LSP, and the LSP can then change its configuration. And so that's what we're using essentially to make sure that the token is set dynamically instead of statically when the LSP starts up. And then you've got the onCompletion method, which handles the actual code completion. So just like the previous one, we get the position of the text document, we get the text before and after, and we send it across to the server. And that's pretty much it. That's all we are really handling on the code completion side. We're not handling diagnostics because, again, the Go LSP is really not doing anything at the moment with the diagnostics. Maybe in the future we would use that for various things, but it's not really utilizing that. And that's pretty much it. Like in terms of the actual data that goes in, we just get the content above and below the cursor, and we just send that across the actual API, which is implemented here. And again, for the API, just like the Go LSP, we're calling we're first calling get completion token, which actually from GitLab, from the API v4 suggestions tokens endpoint, it fetches the JWT, and then it then calls this endpoint with the JWT. Okay, and it constructs the request, which basically consists of your things like your prompt version and current file information and stuff like that. It's doing exactly what the Go LSP does.
Perfect. Thanks so much. It's I have one question. Like when we compare the Go implementation and this one, like so it has all this architecture with registering providers. Do we want to make it like the same in the TypeScript version, or are we okay only having the code suggestions part, or we should make it like extensible, like the way you explained in the Go implementation?
Ideally, I think we should make it extensible, but at the moment we don't really have requirement. Like I'm a bit of a lazy programmer. I would wait for like the requirements to come in before I actually start implementing that. There aren't any requirements at the moment to have multiple code suggestion providers, but the moment we have that, it'll be a good, useful thing to have that pluggable provider. But I think at that point in time, it won't be too hard to implement that. Right, to just create an interface that can be used by multiple providers. So I don't see a reason for doing that. Like it's up to you guys. If you want to bring full parity and you want that support, you can add that in.
Yeah. Okay. Yeah. Thanks so much. It's It's very good. It's really much better now. Much better, especially with the go part. It's yeah. I don't know who writes this very complicated.
That's perfect. And then I was also working on, like, I realized that it's quite hard for people to understand where we are with the extensions right now. And I was trying to, what am I doing? Let's try to zoom in first. I was trying to make something that makes it easier to figure out what's happening where. So basically what I've tried to do is, and this could be useful for others as well, is figure out, what are the projects that are going on in parallel, and what is the state of various things. For example, which are the things that are using LSP? It's only the Visual Studio and the NeoVim bit that are using the LSP. NeoVim is in progress. Visual Studio is already live with the Go LSP. And then you can see the various projects that are happening, just to know like an overview of what all is happening across the extension space, because there's a good chance that you'll be interacting with some of these other people that impact the space. And I've also made a list of people that are actually working on various things. I may have missed people out, and I would publish this list and get the full list of people. But basically, people to reach out to, for example, hey, for LSP integration with Visual Studio, I need to reach out to Mike or Ross, or for NeoVim, I need to write to Ash or Aaron. So who to reach out to. Also, I'll share this document with you as well. And so, in case, because it's a large team, there are various people working on various things. It's a bit difficult to understand who's doing what. And so I'll share this with you as well, so that it's comfortable.
Okay.
Anything else? Any concerns? Anything else you want to know?
I think it's much more information than I expected to get. It's very useful. I was wondering, like, how's the process, because you developed the Go part and the TypeScript server. So I was wondering, so you tested this locally. I did set up this like testing client, and probably will be sending messages to my server to test things. But like, how often do you integrate with the code extension team? I mean, like, for instance, I'm adding like client name support to the TypeScript server. Is there something that I should notify them, or later when we like?
Not at the moment. Like, I think you should work with. I don't think whether the work has started already.
I
To
haven't
migrate the
done
Go
anything.
LSP to the TypeScript LSP.
Yeah.
But once that work starts, then yes, you'll have to inform them of all the changes that you're making. But I'm not sure. Like, I don't think like Mike started working on the integration with the TypeScript LSP at the moment. So, but once that work starts, definitely, it's best to keep them informed when you make changes.
Are they making any changes to the Go language server? Because you mentioned like on Friday that they add some features.
Yeah,
So
there's just a few features added by Ash, especially because they're doing this NeoVim work. That is, so in order to support that, they've done a few things. If I go back here, like at the moment there are no merge requests, but there were a few merges recently. The token check command that I mentioned earlier, and then just some left hook support and some essentially some maintenance work has been done, but that's pretty much it. Nothing great. And you can see the change log as well. The change log on the Go language server thing is pretty useful, because in order to publish, people need to update the change log, and so the change log is pretty much up to date, so you can see what are the changes, and people are pretty good at putting that there so that you can see.
So basically, like tracking, so their project, it would be like enough. They don't make the changes quite often. Okay. How do you still have time?
Yeah, I do, absolutely.
Two of us left here. So how is the code review going across all the teams? Because like I assume you were the only developers that started the TypeScript.
Yeah, this is a new Yeah, this is a new project. So I think what we need to do is make you and Elias maintainer on this project so that you guys can start committing code. Like I would say, because no one's using the code suggestions, you can like iterate quickly, right? So don't worry if you don't get like, you can not be worried about breaking things initially, right? There's like no CI anyway, so there's nothing for you to break. But basically you can, you guys can commit pretty quickly onto the repository. So feel free to like, I don't know how, I don't think I have the access to make you maintainer, but I think Andre or Kai will probably have that. So I think both of you guys should just become maintainers and then just keep committing. You know, I'm happy to review any of the work that you're doing. You know, I can have a look at the you know, any MRs that you have, but just go ahead and directly like commit to the repository as you're sort of getting you know, up until the point when people actually start using this, and then you need to be a bit more careful and have more reviewers. But till then, let's just move quickly and iterate as quickly as we could on this thing.
Okay, certainly. That's even easy. Thank you so much for all the introduction. It was
Yeah, no worries at all.
And the work that you've done, like to set it, it's much easier to proceed when someone has started.
Yeah, well, it was just I just did it over the weekend to figure out, you know, how to, like, how much time would it take? I was trying to analyze that. I said, okay, you know, I'll just build a little bit more, and then I just, you know, ended up doing some, you know, to getting it to some baseline spot. But there's a long way to go, right? There's no tests and stuff like that, like I said. So there's a lot of work that is still needed. And I'm sure you guys will do a brilliant job. I'll try to help out wherever I can. As well.
We'll try to. Hopefully we'll do a brilliant job. Thank you so much. But I think that's it for now. If I have any, I will have questions like in future, but like for now, I'm good.
Sounds great. It was good to speak to you. I hope this has helped, and I will publish the recording to YouTube soon.
Yeah,
all right, thank
so
you.
much.
Bye.
Have a great day. Bye.